Uh, Hello everyone. Welcome to the group presentation for cloud computing. We are group 11. We are going to present on the topic clustering. My name is Srikar. So before we jump into the topics associated with clustering, we need to understand what clustering is. Clustering is an unsupervised machine learning task where the machine learns on its own using the data, and it will classify the objects into a particular class. So clustering is a task of grouping a set of objects in such a way that objects in the same group are more similar to each other than to those in the other group. It is a main task of data mining, and it is a common technique for statistical data analysis. It is used in image recognition, market research, and many more. So we have different types of clustering. The notion of cluster cannot be precisely defined, which is one of the reasons why there are so many clustering algorithms. So the first type of clustering algorithm is partitioning clustering. The second type is hierarchical clustering. The third type is density-based clustering. The fourth type is model-based clustering. The fifth type is k-means clustering. My teammates would go in depth as to what each clustering algorithm would do. And before me handing it over, what do you guys think? What are the applications of clustering and why is clustering important in industry? And handing it over to Shalvik.
Hello everyone, my name is Shalvik Shah. I will cover partitioning clustering and hierarchical clustering. So, partition clustering is a technique that divides the data into a set of groups. It is also called as centroid-based method. So, in this clustering, this is the cluster that forms that the distance of data points in that cluster is minimum when calculated with other centroids. Though this is hierarchical clustering. So in this clustering technique, it divides the data set into a number of clusters where the user doesn't specify the number of clusters to be generated before the training model. This type of cluster technique is also called as connectivity based method because it connects the clusters. In this approach, it is the simple partitioning of the data set will not be done, whereas it provides us with the hierarchy of the clusters that merge with each other after a certain distance. So, guys, I have a question for you. So, what is the difference between hierarchical clustering and partitioning clustering? Now, I will pass to my other teammate, Ritik.
Coming to density-based clustering, in this clustering techniques, the clusters will be formed by segregation of various density regions based on different densities in data plots. And the main features of density-based clustering is they discover clusters of arbitrary shape, and which is, I believe, is an important feature in any clustering technique we see. It handles noise. It is one scan algorithm and it needs density parameters. DBSCAN, which is also called density based spatial clustering and application with noise, is the most used algorithm in this type of technique. And the main idea behind this algorithm is there should be minimum number of points that contain in the neighborhood of a given radius for each point in the cluster. So the question, if we see, then what can be the basic assumption for this algorithm? Perhaps if we see only the assumption that we can safely make here is there is no noise in the data, and there are clusters in our data which we hope to discover, and which should be assumed for every clustering technique, I believe. Another type of clustering is model-based clustering. In model-based clustering method, it attempts to optimize the fit between the given data and some mathematical model. In such methods, they are often based on the assumption that the data are generated by a mixture of underlying probability distributions. There are three different techniques. which are conceptual clustering, neural network approach, and the most common one is expectation maximization clustering using Gaussian mixture models. You see there's a figure below here. It's an example of simple mixture based density based model based clustering. Sorry, and there are two clusters. Each follow a normal and a Gaussian distribution with its mean and standard deviation. Now, Kamlesh will go over another clustering technique. Thank you.
Thanks, Riddhi. Hello, everyone. This is Kamlesh Singh, and I will go briefly over k-means clustering. This is unsupervised learning algorithm because the target variable does not have any kind of label at all. And that's why the idea behind is to classify the dataset through a certain number of clusters. This technique is also called as a centroid-based algorithm or a distance-based algorithm, where we are trying to assume to have k numbers of clusters where k can stand from 2 to n, and each cluster is associated with a centroid where each point or each data point is assigned to the cluster with the closest centroid. The whole aim of k-means clustering here is to be able to minimize the sum of distances between the data points and their respective cluster centroid. Let's see the steps involved in k-means clustering. As you can see here, in general, there are 6 steps involved. The very basic step is to start with assuming the number of clusters that we need. In the example shown here on the right-hand side, we have 2 clusters. So in this scenario, we have k is equal to 2. The next step is to randomly select the centroids among each cluster, and that's why we have to select k random points from the data as centroids. Then we are trying to assign all the data points to the closest possible cluster centroid. And then finally, we recompute the centroids of these newly formed clusters. We repeat the last 2 steps, step 3 and step 4, until we reach the stopping criteria, which includes 3 main factors, or either of that, where we have the centroids of newly formed clusters do not change at all, meaning that the values of centroids found in this newly formed cluster is exactly same as the centroids that we found in the previous step. Or the second stopping criteria is the data points remain in the same cluster. And the last but not the least is that the maximum number of iterations have been reached. So that was a quick overview of the k-means clustering. With that said, my question to you is, what do you think k-means clustering is and why is it useful? I would highly suggest you all to pause the video and try to answer it on your own. And please feel free to refer back to the previous slides in order to answer this. With that, I would like to pass on to Karan to go over the next details.
Yeah, thank you, Kamlesh. Hello, everyone. This is Karan Shah, and I will be covering advantages and disadvantages of k-means clustering. So let's begin with the advantages of k-means clustering. First is it is very easy to implement. Second, it will be useful for large dataset as well as the smaller database. So it can be scaled for large datasets. Third one, k-means clustering will produce the tighter clusters comparatively to the hierarchical clusters. Fourth one, an instance can change cluster when the centroids are recomputed. So when the centroids are recomputed, it will change the number of clusters. Next slide, please. Disadvantages of k-means clustering. First one, it is difficult to predict the number of clusters in the beginning, which is called the k value. Second one, initial seeds have a strong impact on the final result. So based on the number of seeds we have to decide in the beginning, and based on that our final result will be generated. Third one, the order of the data has an impact on the final result. So and fourth one, it is sensitive for to scale because the rescaling may impact the final result or the outcome. And so I have a question for you guys. Like, what do you think? What is the most advantage and what is the most disadvantage of the k-means clustering? Yeah, that's it. Thank you.